So what is Coulomb's law? F is proportional. Okay, what they have found? The force.
So F is equal to
yes.
Proportional. So it's proportional to the Q value.
Yes. They have found that the force between the charges was proportional to their charges. Okay, charge value, you could say the magnitude of the charges. Okay, and the distance between both charges, the force was inversely proportional. Okay, so when you have written that F is proportional to Q1 Q2 over R square. Okay, so there is a constant proportionality constant, that is K Q1 Q2 over R square. That is Coulomb's law. Okay. Now, where if I write Q1 is what? First charge. Okay. Q2 is second charge. And what is their unit in Coulomb? Okay, that is C. Okay. So whenever you will write the charge of the units of the charge, they will be Coulomb. Okay. What is the R? Perpendicular
radius.
Distance. Not this radius. It's perpendicular distance between Q and Q. Okay.
Yeah. Okay.
If it's R, that does not mean that it's a radius. It is a perpendicular distance. Okay, between Q and Q2. Okay, getting my point? So this is Coulomb's law. Suppose I'm taking a force. Suppose Q1 is this, Q2 is this. Okay, if Q1 is plus 2 Coulomb charge and plus 1 Coulomb charge.
So each Q you're referring it to as two different particles?
Two different charges.
Okay.
Minus 1 Coulomb. Okay. So since they are like charges or opposite?
Opposite.
If they are opposite, then there will be attraction between them?
Yes.
So can I represent like this? This is what?
That's like going towards each other.
Attraction. Okay. F.
Yeah.
Attraction. Okay. Suppose you have, and always see, there is a, on which line it will exist, the force on which line it will exist. It will exist on this perpendicular line. Okay. The force will be on this line. It will be the shortest distance between the Q1 and Q2 possible. Okay. Suppose this is Q1 and Q2. Q1 is plus 2 Coulomb and Q2 is plus 2 Coulomb as well. Okay, it is plus 2 Coulomb. How the force will act? Since they are like charges, what will be the force?
The net force? Or?
No, not net force. What kind of force? It will be repulsion, attraction.
Attraction force.
Attraction.
Or you're talking about the right side one?
They're like charges. So what will be the force? Repulsion or attraction?
No, one of them is plus 1 and the other one is minus 1.
Here. Can you see the screen?
Yeah, I can see it.
So what I have written here? Plus 2 Coulomb.
Well, nothing loaded up on the left side for me. Okay, I'll just quickly rejoin.
Okay. Okay. So if you have plus 2 Coulomb here and a plus 2 Coulomb here, what kind of force will be?
They'll repel.
Repel, right? So if it will repel, and on what line it will repel? On what line? The perpendicular distance. What is the perpendicular distance of between this? This is the shortest distance possible, right? The perpendicular distance. So the line is this, right?
Yeah.
Okay. Joining them perpendicularly. always the force will always be on this line. I'm telling you again and again this because this is really important. And when you will have
Okay.
so many vector forces between the charges, okay, you will have to see the vector addition. You will have to see the vector addition between them. Okay, so this is the r. What is the distance? I always talk about this is r. Okay, the perpendicular distance
Okay,
between
perpendicular distance.
this is starting from the first charge to the ending charge. That is r. Okay, remember
Okay.
this?
Yeah.
Okay, got it. So this is the line joining. You could say the line joining between both charges. Okay. So for now, K is called proportionality constant. Proportionality constant. And what is the value of K? That's 1 over 4 pi epsilon 0, right? Okay. And the value.
Wait, isn't the value of K 9 times
Yes,
10 to the power
the
of 9?
value, it's the value 9 into, but this is the formula. Okay.
Oh,
Its,
okay.
its value is 9.0 into 10 to power 9 Newton meter per coulomb, something like that. Yes, Newton meter square per coulomb square. Okay.
Yeah, okay.
So that is, you could write 8.99. That's better instead of writing 9.0, somewhere 8.99. Okay, that is the value of K. Okay, what is epsilon 0 here? Epsilon 0 is permittivity. Okay,
Okay.
permittivity of free space. Okay, it is called permittivity of free space.
Okay.
Permittivity of free space. And the value of permittivity is also it is epsilon 0 is 8.85 into 10 to power minus 12 coulomb square over Newton meter square. Okay, so these are the two constants you have to remember. Okay, K is equal to 1 over 4 pi epsilon 0, and epsilon 0 is permittivity of free space. Okay.
Okay.
Okay, got it?
Okay. Yeah.
So the formula of Coulomb's law, Fc can be written as K Q1 Q2 over R square, or Fc can be written as Q1 Q2 over 4 pi epsilon 0 R square. And what is R? That the
perpendicular distance
between two charges. Okay.
Yeah.
These are two formulas that you need to remember. Q1 Q2 has to be in Coulomb and R in meters. Okay, the distance in meters. Getting my point?
Okay.
What is the value of E? If it is an, suppose Q1 is an electron, what is the charge? What is the charge of?
That's negative. The electron is negative.
Yes, negative. So what is the charge?
Negative 1.
Yeah, negative. What negative 1?
Coulombs.
No. What is the charge of electron? What is the value of E? 1.6 into 10 to power 19 Coulomb. Always remember that. Minus E. What is the charge of electron? Minus E. That is minus 1.6 into 10 to power 19 Coulomb. Okay, that is the E value. Okay, and if it is an electron.
Okay.
Okay, minus E. Always say that it is minus E. Okay, not minus 1 Coulomb. Q2 is, if it's proton, then it's plus E.
Okay.
What is plus E? That 1.6 into
1.6.
19 Coulomb. Okay, but positive. that is the charge of proton. Okay, always remember that there, because multiple times in the problems they will use electron and proton. You should remember the charge value.